Today, I'm going to share a little bit about like the N+1 problem. Um, yeah, just talk a little bit of what that is and ways to work around it to mitigate the problem and also to prevent it. My name is Rafael. I work at Tosca, and you can find me pretty much everywhere by that handle there. So first, let's walk through an example to understand a little bit better about the problem. So imagine we have a model called match, which represents matches that we store in a database. And every match is associated with a game, right? So the match would have, I don't know, duration or some information, and a game could be like, could have like the game name, just like could be anything, Pokemon, I don't know. And then you imagine that we want now to generate a report of like the last 100 matches with their duration and showing up the game name. So if we were to do that in Ruby on Rails, it could look like something like this. We could query the last 100 matches and look for them and call like something that will make that report. And then we can call uh, we can fetch the duration of a match and report that, and also like the game name. So although the game and match are different models, they are associated, and then we are capable of like retrieving that information and passing that through the report, right? So that is done for us by this ability of like the active record providers of like lazy loading stuff. So lazy load takes care of us of like fetching that data that lives in the game, and in our case like the name, and presenting that for us, and the query will fire up here in this line 13. So lazy load is like very handy, right? Super handy because it gives us this flexibility is and that ability. So you query the desired data on demand. You don't need to stress a lot about it. uh, but it also introduced a problem. So because what happens is that because we are looping through the last 100 matches, right, and we are getting the game name here in the line 13 inside that loop, it means that we are firing up a query to the game table every time that we try to fetch that game name. So what happens is that for in order to generate this report, we do a query for the 100 last matches, then we do 100 more queries for every game inside that loop. And that's when you get like 101 queries, and that's what we call like the N+1. That's our N+1 here. So we really if you were to look at the logs, or if you can like jump in a console and inspect the queries being performed behind this, you would see like the first query to get the last 100 matches, and then you can see the subsequent queries to the games table to fetch every individual game related to the match. So that's all what the N+1 is about, really. So the N+1, if I could put in another words, it's when we execute any additional queries to fetch the same data that we could have got from running just a single query, because like all that 100 extra queries could be just one. And yeah, the N+1 problem becomes more evident as application grow, because applications grow because its impact is multiplied by the new scale, right? So a lot of times they can leave a notice. You wouldn't bother us, but as our applications grow in size and in number of requests, etc., it gets multiplied by that. The impact of it gets multiplied by the scale, and RIMs like the active record, the abstract the how the queries are done like under the code, like under the API interface, and that makes it easier for us to fire too many queries without noticing. But despite it is also always like or often related with RMs, is not limited to it. Like we can always like write SQLs queries ourselves and do them in a loop, or like inadvertently create these N+1. We can always as well like fetch data from other data sources like APIs, cache, and in a similar manner, if we do that without paying a lot of attention on the code that we're executing, we can lead to N+1s. So how can we mitigate that? One alternative for in this particular case that we are showing in this example, we could make use of the eager loading capability to solve this N+1. So this strategy consists of just like loading up from all the data of interest alongside our main query. So in our example, we could use this includes method available from also from like the is one of the API methods of like active record that allows us to include any association table or any model that is associated with our main model that we are firing up the query. So it loads both of these at the same time, in quotes, at the same time. So in this case, we could do like includes game because we know it that's associated with the match. And by the time it gets to this line that we fetch the name, the information of the game would be already loaded. So if we were look to the if we were to look to the queries, then we would see that there will be only two queries, one for matching all the tasks or sorry, not task matches, and then we would get all the games associated with that match, and then we are saving up like all that 100 extra queries, and we are performing those two queries. With the includes active record, we'll make sure that it load everything that it needs using the minimal amount of like queries possible. So we avoid doing a lot of queries. We are not lazy loading anymore. There are also other alternatives to includes. I think there's like prefetching or preloading. There are some differences as for these methods. They often differ in the way that they're going to fire up the requests. The SQL queries may end up being like a join or a different SQL structure. But the idea is the same. It's kind of like batching loading everything up front. So you don't need to load as you go, load in a loop or something. In a similar manner, I was just saying like we could end up with this problem if we were working with cache, for example. Imagine we are using like the Rails cache and we have the game name, for example, associated with a key, and that's stored in a cache, and we can retrieve from the match ID. If we were to use like simply, again, like just querying that in a loop, what we're going to be doing is like we're going to fire up like 100 more requests to this cache in order to fetch that information. And we could be bursting out like Redis or main cache or whatever cache solution that we are using under the hood. And just like we have alternatives for that from the active record, we can also use alternatives to bulk load a lot of keys. So for example, we to mitigate this problem here, we could use, like get all the keys from the match IDs and then read multi, which is a function, an API function of the Rails cache that exposes you the method of like book loading a set of keys. And then they get all mapped key and like game name. So loading everything up front and then passing down the information to the report. So again, that's the same nature of like way of mitigating the problem. It's kind of like we are bulk loading everything up front, so we avoid firing up too many requests. But there are some times that we don't quite have this ability. I mean, exposed by the APIs. So for example, that we don't always have like associations to eager load from the data. So we are not always dealing with like connected models. Some information can be in a model, some can be in the cache, as I said. Some other information can live in another service. So you would do a different API call, different database. There are many possibilities, and while we can always implement batch loading or this strategy ourselves, we can come up with our own solutions to deal with it. there are other solutions as well that are meant to work together and diminish the N+1 problems, just like data loaders. In Ruby, for example, I found like two good implementations that I played a little bit with them before, which is the batch loader and data loader. Data loader is also became quite popular as well, like in a trend after like the boom of GraphQL. If you ever work with GraphQL, because it's very focused on the N+1. So sometimes you're transferring the problem of the client to the server, and then you need solutions to work around the N+1 in the server as well. And data load is another batch loading strategy. So what is the impact really of like of these N+1? I can only tell you that you would be surprised about the performance of games, because we end up with like healthier performances or healthier dependencies when we perform fewer queries, right, to our data sources. So whatever that is, like if that is an external API, your database or a cache, you fire less requests to achieve the same objective. So they have more room to grow with fewer route trips for your application as well. So your application has often to wait less for the data to come and to assemble and to report the output, right? And of course that comes with like memory costs to load everything up front, because you need to load everything in a memory. So if you really need to load everything at some point, then that batch loading, eager loading should be appropriate. But if you don't always use everything that you're loading, then you can be wasting computation. You can be wasting like memory usage. But ultimately, what it leaves us is like with more room to grow. It means that we can scale further our applications, because our applications are not firing too many unnecessary requests to any of our dependencies. So yeah, we've talked a little bit about like what that is, like ways to mitigate, and perhaps a little bit of the impact. I've worked in projects that I could like save up like hours of work if you would sum like everything that the code was doing. You could save up like hours of work and then processing, and it's really amazing. And another trend would be like how we prevent lazy loading from happening if if we are really keen to like mitigate this problem as soon as possible, or be a little bit more proactive. That there are always like manual alternatives, despite the typo there. But yeah, that like you can transform like models into hashes or classes. So you work with raw objects or like some sort of abstraction, and you can always like audit manually all the features and code, try to chase up these loops and everything. That means that you can safely work with them without like worrying about dispatching new queries. But if you're transforming everything into new classes or hashes, we lose that rich API, and we would need to like reassemble or re-expose anything on any functionality that currently lives in our models, or like our main entities. So that's not like really ideal, but it's one way that we can chase up these things. Another way would be to go and rely a little bit more on automated alternatives. So for example, we could be using a monitoring tool to monitor our production environment, just like New Relic or any other profiling tool. They would create a breakdown of your application and show up like, oh, what's the most impactful queries, how often, or what's the average number of calls to that queries within a request or within a background job or something like that. And there's also ways to track and be a little bit more reactive on these things during development. So for example, Bullet is a gem that tries to alert you when to introduce EG loading, and it looks at your code, and while you're developing, you get some alerts and some hints on what to do in regard to that. So these are great tools, great things. we let the tool works for us, right? So they alert us, and then we can act a little bit faster in an automated way. But we are still kind of like reactive to the alerts, whether that is in a prod environment or a dev environment. We're still reacting to it. So could we be a little bit more proactive? And recently, at least if you're using Rails, in the Rails 6.1 was released with the strict loading, which is a great alternative to be a little bit more proactive in the sense that if you really don't want lazy queries to be um, fired up, you can set now a new property in the model, or maybe you can set by association by the model, or even like a global configuration. And if you set that strict loading as true, whenever you try to lazy load an information of any of that association, that model, or anything, it will fire up. Actually, you throw a request, an error to and to indicate that you're breaking a violation, which is like the strict loading violation error. And that exception will tell you that the resource that you're trying to do and trying to fetch is not fetched already and cannot be lazy loaded. So by doing that, we are being a little bit more proactive. Lazy queries cannot be created anymore. And we can change it on demand. We can change it and play and see how that goes, see if that works best for us, how that can be really useful for us. But yeah, on another note, while this is great for at least our models, it's just limited to our models, of course. And so that there are always cases that we would need to go there and implement a strategy to fix and to work around and mitigate the N+1, just like the example I was giving, like with data loaders. If your data is not really connected within these associations, there's not a lot that you can do. So yeah, just to do a quick summary, because yeah, this is just a short presentation, but I think it is really powerful to understand some alternatives, because I ran into this problem multiple times, and I'm always reminded that, like is one of the things that you want to know, or you want to remember of alternatives to work, and there are always like new alternatives coming up in the community, so it's always good to keep them in mind. So the N+1, just to summarize, is not always noticed, but it starts to become an issue as our applications grows and scale. It's often related to RMs, but it's not limited to it. Other ways that you can end up with that problem. Batch loading strategies like eager loading, data loaders helps us to mitigate the issue. Strict load is in Rails 6.1 is really good because it allows us to prevent that issue in the first place. And there's no silver bullet, I guess. A mix of like these tools, these strategies will contribute to of the overall quality of our systems. Like there's no single solution. There's nothing that you can plug and play and then it's all gone, right? And that it always requires us to maintain, think about the problem, see if that thing that we are trying to do solves for this particular issue or not. And yeah, mitigating it helps us out to keep our systems like healthy as they grow, and then we have more room to grow, and we all have happy users and yeah, healthy systems. So yeah, that's it that I had to share today about the eager loading or the N+1 problem and some strategies to mitigate that.
Great, thanks,